Question number 5. So this figure is showing us a direct current circuit. The power dissipated as heat by the 4 ohm resistor is 4 watt. What is the resistance of resistor R in the circuit? So for this question, we have to find the resistance R, which is this one lah. So first what I'm gonna do is I'm gonna label each of these resistor. So this is R1, this is R2, this is R3. So sekarang ni dia ask kita cari, the question asks us to find the value of R. So what I'm gonna do first, I'm gonna calculate the value of current flowing through the circuit first. Okay, so the current flowing through this external circuit will be the same as the current flowing through this resistor here. Okay, so the current here will be known as I1 lah. Okay, so how do I do that? I'm gonna use the power that has been given by the question. So the power across resistor 1, the equation should be like this, I square R1. Okay, I square R lah dia punya equation. So since we have the power, we only have to find the current. So this will be the square root of P1 over R1. Alright, so this is I1 equal to 4 over 4. So this is gonna be equal to 1 ampere. Okay, so lepas kita dapat the value of current flowing through the external circuit, so the current flowing through here is also equal to I1. Okay, semua di sini mesti I1 lah, sebab ini adalah current flowing through the external circuit. So this is I1, I1, I1. But when it is at this junction, it will break into 2. So this is gonna be a different current lah, okay? A different value of current. So what I'm gonna do is I'm gonna label this as I2, this is I3, okay? So let's focus on I1 dulu. Sebab from this current at the external circuit, we can actually find the effective resistance. Okay, so lepas kita dapat effective resistance, kita boleh guna the effective resistance punya formula untuk cari the value of R lah. Okay, so how do we do that? We know that V is equal to IR. Okay, so the V that we are using is the 10 volt, I is I1, R is the effective resistance lah. Okay, so sekarang ni kita mau cari effective resistance. So arrange for effective resistance. It's going to be like this. So V is 10, I1 is 1. So the effective resistance is equal to 10 ohm. Okay, so sekarang ni kita akan guna the formula of effective resistance untuk cari R. So how do we solve this? First, we are going to solve these two. So since this is in parallel, it is going to be 1 over R plus dengan 1 over 8. So what I'm going to do is I'm going to write it down here. So 1 over R2 plus 1 over R3 to the power of negative 1. So lepas kamu simplify it, kamu akan dapat this diagram lagi lah. So this is so these two will be connected in series after kamu combine these two resistors together. So that is just plus R1 plus R2. So you just have to plus them together lah. So that is just plus R1. R1 plus dengan the combination of resistor 2 and 3. So you will should get 10 ohm lah. So this is 10, this is 1 over, oh, I can't do it that way. I have to write it begini pula. 1 over R plus 1 over 8. Plus dengan 4. So kamu rearrange sendiri ya, bagus-bagus. So you should get the resistor to be equal to 24 ohm. Okay, so sekarang kita ada sudahlah the value of R, which is 24 ohm. So sekarang ni question asks us to calculate the current passing through resistor R. So through resistor R, that is basically the kejap yeah, so that is basically the current at number 2 lah. I've labeled it as I2. Okay, so I've drawn it before just to save time. So since we have the value of R2 already, this is 24 ohm. Okay, so lupa pula, ini R23 lah, R23, and then the effective resistance. So first step that you need to do is you need to calculate the value of I2 kan. So macam mana kita mau buat ni? You need to, okay, wait, I'm just actually looking at the answer scheme. So what they did is we have the effective resistance already. So that is 10 ohm, the one that we've calculated before. Okay, so kita sudah ada, yang ini adalah 10 ohm. So sekarang ni, actually, instead of using this diagram here, kalau kamu buat step yang macam ni kan, kalau kamu mau calculate the current flowing through a resistor, kamu perlu buat the reverse step. Kamu perlu look at when it is simplified and then go towards here supaya kamu dapat the current flowing here lah. So what I'm gonna do is I'm just gonna label this again. So this is the one that we've obtained earlier, which is 10 ohm, and R23 is basically 1 over 24 plus 1 over 8 ohm to the power of -1. So this is 6 ohm lah. So this is 6 ohm. And then I'm just gonna label this again, 24 ohm. So how do we solve this? We are gonna work from this diagram to this middle one and then to the original circuit. Okay, so what is the first step? The first step that we are gonna do is we are gonna find the current flowing through the, oh my god, this is actually a little bit difficult to explain, but I'll try my best. Okay, firstly, so what do we know from this circuit? So from this circuit, we know that the voltage should be equal to the current flowing here, which is I1, and the effective resistance. We know that the current flowing here, I'm just going to label it with a different color. So the current flowing here is labeled as I1 lah, yang tadi kita kira, which is I1. So the current flowing here is also I1 lah. I'm just going to label them. Okay, so this is I1, this is I1. So what we know from this circuit is we know that the voltage is equal to I1 times the effective resistance. So from here, what do we know? We know that V is equal to 10 volt, I is equal to 1 ampere just now, and then R is equal to 10 ohm. Okay, so now let's look at this second circuit here. So we know that this current here, what is the current flowing here? It is basically I1 juga lah. So I1, and then the current flowing here is also I1. Okay, so wait, I'm just gonna label I1 here, and then the current flowing through this resistor is also I1 lah, sepatutnya. Okay, right, so this is I1, this is I1, this is I23, which is equal to I1 since they are connected in series. Okay, so what do you need to know? For series circuit, the connection will be, the current flowing through the circuit will be equal lah. So this is gonna be equal to 1 ampere. Kenapa juga ada 0 tu? 1 ampere lah. Okay, lepas tu, what do we know about the voltage? the voltage untuk series circuit is not equal, so the voltage across capacitor 1 will be the addition, the total voltage across the circuit will be the addition of the voltage across resistor 1 plus dengan resistor 2 and 3. Okay, so that is what we know. And then what can we do here is we can actually calculate the voltage across capacitor 2 and 3 lah. So how do we do that? We can actually use V23 equal to IR, so that is I23 R23. Okay, so this is equal to 1 times with 6, so we know that the voltage across resistor 2 and 3 is equal to 6 volt. Okay, so that is the information that we know from this circuit here. So now for the third circuit, for this one, what do we know? We know that the current here is I1. This one is also I1. But at that junction there, it will be split into two current. They will take a different path. So this is a different set of current lah. Okay, they have a different value. So this is I1. This is I1, but this is I2. This is I3. This is I1. Okay, so that is the flow of current from here. So firstly, what do we know about the current? We know that the current I1 is gonna be equal to the addition of, oh wait, ayan, I2 plus I3. And for this situation here, what do we know? For parallel circuit, since we have the current here, it will be equal to I2 plus I3. So ini adalah untuk parallel circuit. This is for parallel circuit. The current here will be split into two. They are not equal. However, the voltage for these two resistor is gonna be equal. Okay, so that is what we know from the third circuit. So after that, we can then find the value of current I2 by using V2 equal to I2R2. Okay, so I2 is equal to V2 over R2. So since we know that the voltage across the resistor 2 and 3 should be equal, the voltage across resistor 2 is equal to 6 volt lah. So di sini kita akan dapat 6 bahagi dengan 24. So the current through resistor number 2 will be equal to 0.25 ampere. Okay, so I hope you can understand what I've been trying to explain here. So basically what you're gonna do is you are gonna do the reverse method. So you just have to find the information for each of this circuit lah, supaya kamu boleh senang terus cari apa yang perlu dicari. But what you need to know is the characteristics lah. Again, the characteristics for series circuit apa, the characteristics for parallel circuit apa. Macam tu saja. Okay, alright. So question C pula, kita perlu cari how much time will it take for 75 joules of energy to be dissipated from resistor R. So for this question, it specifically mentioned resistor number 2, so that is W2. The equation is gonna be VIT, but this is gonna be for resistor number 2 lah. Okay, so dia cakap dia mau 75 joule of heat dissipated. Dia tanya pasal time. So the voltage across resistor 2 is 6 volt. The current for resistor flowing across resistor number 2 is 0.25 ampere. So we need to find the time. So rearrange for time. So calculate that, you will get 50 seconds as the time for 75 joule of heat to be dissipated from resistor number 2. Okay, so alright, so basically for this question, this bit is the hardest part, but if you follow the step by step, you can actually understand it more easily if you try to find the information for each of these circuit lah. Okay, just make sure kamu faham apa characteristic for series circuit and characteristic for parallel circuit and how the current flow for each of these circuit lah. Okay, repetitive sudah saya cakap. Alright, so that is basically for question number 5.